Alright, let's look at the practice exam 1, problem number 7, part B. Alright, so this is improper integral of type 2 because there's a discontinuity at x equals 3 because denominator becomes 0. Alright, 3 is actually in the middle of this interval here. So what I'm going to do is I'm going to split this into integral from 0 to 3, then the same thing, 1 over x minus 3 quantity squared dx, and then we have integral from 3 to 5 and the 1 over x minus 3 squared dx. Alright, so let's look at the, I'm going to call the first one I1 and the second one I2. Alright, so first let's look at the I1 first. Alright, so integral 1. Alright. So since the trouble is when x equals 3, so 3 is the troublemaker here, I'm going to replace it with t. So you have integral from 0 to t, right? Then limit as t approaches 3 from the left, right? Then, so integrand is 1 over, actually, can I rewrite it as quantity x minus 3 and raise it to the negative 2, right? And then with respect to x. Alright, then this is going to be, right, we still have a limit as t approaches 3 from the left. Right, then you have antiderivative of that would be, right, so we have x minus 3, right, add 1 to the power, which is negative 1, and divide by that power, so it's negative 1, right? Then you're going from, right, 0 to t, right? So we can do this because derivative of x minus 3 is just going to be 1, right? So we have that. Alright, then plug in t and plug in 0 you have. So you have a limit as t approaches 3 from the left. Alright, if you plug in t, you're going to get, right, so first you have a negative sign there. Alright, negative power is reciprocals, 1 over, right, plug in t for x, t minus 3, right, and a minus, there's a plus sign here, right. Then you have, so it's a 0 minus 3, so it's going to be 1 over, right, negative 3, right? So we have that. Alright, then if as t approaches 3 from the left, you can see that the denominator approaches 0, right, from the left. So you can think of it like a slightly smaller than 3, so it's going to be a negative, right? But so 1 over negative, so something really close to 0, but it's negative, is negative infinity. But we have a negative sign, so it goes to positive infinity, right? So this is going to be positive infinity minus 1/3 is still going to be positive infinity. Alright, so once one of the integral is divergent, then you can conclude that the original integral is going to be divergent. So therefore, you can just simply say this original integral is divergent. Right? Then you don't even have to look at the second integral, because once one of them is divergent and the original one is divergent. Right? That's it. I hope that this was clear.